this is weather advanced by the forecast agent. How, as you can see here in the Baltimore, actually the Baltimore, Maryland area, now actually heading on off the coast, not off the coast, but around, let's see, Aberdeen, Bocors, heading on into Yukon and maybe Salem, here in parts of Delaware. We do have some severe weather to report to you. And as Dante said in his post earlier, this area did have the potential for severe thunderstorms. Now, as I zoom my map in, maybe severe thunderstorm warning has been issued to some areas, including Northeast, Newark, Chesapeake City, Concord, Lakesport,
Oh, my name's Steve Eves. I'm here from Akron, Ohio. We're at Tommy Higgs Farm, real close proximity to the MDRA's field. But unfortunately, right now, it's pouring down rain.
That's true. You scrubbed today, but what did you bring with you?
I brought my Saturn 1B with me. It's a model I started about 18 months ago. And 25 feet tall, somewhere in the neighborhood of 900 pounds, fully loaded. We're flying it here on a Central P8000 Loki research motor. And we also have 5 Loki N3800s in there, 4 in the first stage. And this is actually a 2-stage rocket. We're going to stage to a single N3800. Projected altitude somewhere in the 6,000 foot range.
Okay, now this, told you, you said 18 months. What's this actually made out of? Is it made out of cardboard, fiberglass tubes, kitchen sink?
There are a couple kitchen sinks in there, but basically it's the same construction process I used on my larger Saturn V rocket. The entire outside of the rocket is a fiberglass skin, and we actually used a lot of plywood. And actually this is locked precision 7.5-inch tubing here that we fiberglassed over. The actual 30-inch tubes are fabricated up out of cutting centering rings and then wrapping them with Lewin plywood and fiberglass on top of that. So it has a pretty substantial inner structure to it. Should handle the thrust just fine. They end up a little heavy that way, but I'd rather be a little heavy and strong than have something that I was questioning how well it was built.
True. Now the second stage is going to break apart right where the, what's it called there? It's the, right above the tubes?
Yeah, these are, in the real rocket, these are actually fuel tanks. NASA needed a rocket to put some hardware up into space, so they basically took a bunch of existing hardware, put it all together, and they ended up with a Saturn 1B rocket. So these are actually the fuel tanks. And yes, we split apart just above where the fuel tanks end. In a 2-stage rocket, you need to have fins to stabilize the second stage. And being as also a scale model, I couldn't just put fins on it. So what I did to overcome this is we have fins that actually rotate out from the body. The fins are actually part of the skin of the rocket. So when the rocket stages, I have 4 fins that will actually rotate out, open and lock before the second stage motor ignites.
Okay. How many fins do you actually have that are going to come out?
There's 4.
Okay, and how, what mechanism are you going to use to get them out and keep them locked?
Well, what we used was, there's 4 pneumatic cylinders. Well, there's actually 5 pneumatic cylinders in there. And these pneumatic cylinders sitting on the pad are fully charged with about 110, 120 pounds of air pressure. And as the rocket stages, there are 4 aluminum pins that are attached to the first stage. So as the rocket stages, it pulls these 4 pins that are keeping the fins closed out. Pneumatic cylinders take open, the fin will arc open, and at its furthest most point, it hits a latch, which actually latches the fin open. It doesn't rely just on the air pressure to hold it open, they actually lock into position.
So the air pressure is just to get them there.
Correct.
Something else is going to hold them.
Yeah, they will actually be held by a mechanical latch. Because the stresses of a rocket, and you'd have to put 200-300 pounds of air pressure against them to get it to hold substantially enough to fly it on it.
Well, now, are these things going to be retracted on recovery? Are they going to stay open?
Well, the problem with that is on our Saturn V flight, we actually had some webbing that got wrapped around the fins, and we still recovered it, but it wasn't the way we wanted to recover it. So one of the ideas I had with this was to prevent shearing off of the fins when it hits the ground, as well as a parachute getting tangled on the fins. When the nose cone pops off, it will close a switch. We have a valve inside there that will switch the air pressure from the open mode on the pneumatic cylinders to the closed mode. And a fifth cylinder will actually release all four catches at the same time. Then the pneumatic cylinder will pull the fins back closed.
Okay, so you're gonna have hydraulics undo the physical latch and bolt it open, and then the hydraulics is gonna pull them back in.
Yeah, it is actually pneumatic. It's not hydraulic.
Okay.
It's air. We have a 3,000 psi air tank in there supplying the air for the flight.
Have you actually tested this on the ground to make sure it's going to work?
Yeah, I tested it on a series of probably 25 to 30 consecutive open, close, open, close, open, close. Functioned every time.
Okay.
The second half of this is we actually have a switch on each fin that is a confirm lock switch. So these fins actually have to open and lock before the computers will be able to fire the second stage motor. I do not want this thing lighting a motor without the fins actually locked into place.
Well, you have a little bit more than that. Not only do you have the fins have to come out and the interlock has to be closed to verify electronically that the fins are out and locked, but you got something else in there too.
Yes. Every system in this is overlapping. Our recovery systems on both first stage and second stage are overlapping, as well as we have radio control systems for a third fail-safe on that. Our fins have to be open and locked as a fail-safe for both ignition systems. There are two ignition systems for the second stage. One is through an Xavier timer. The other is through an Arch altimeter that we've reprogrammed as a timer. So we have to have signals from these two inputs. We have to go through our fins to make sure our fins are open and locked. And thirdly, we are going through two tilt devices. Both of them on this flight, for this flight, are programmed at 20 degrees. If the rocket is more than 20 degrees out of vertical in any axis, the second stage motor will not light. Simply what will happen is the altimeters will take over, will sense apogee of the second stage. Nose cone pops off, fins close, and we recover it without ever firing that second stage motor.
Who makes these tilt devices?
One of the systems we have in there is from Frank Hermes, is tiltometer. Frank actually flew in for our flight this weekend and spent some time yesterday reconfiguring. We changed the tilt meter out, and he went through it, cleared it all, checked it all, and it's up and running. The second system that we have is one built by a friend of mine who is a computer specialist at our local college. He's also a very avid radio control guy. His name is Craig Crum. He's been working on this on and off for about the last year, and about 2-3 weeks ago we actually got a unit into the rocket and we're testing it. But what we actually did is we set the second stage up and we would tilt it 20 degrees out of vertical, and as soon as this electronics saw we were 20 degrees out of vertical, it would open a switch. If we tilt it back within 20 degrees, it closes the switch. So it is a simple open and close, go or no go switch for the igniter on that second stage.
Is this like a little ball bearing that moves back and forth, or what's the main gist for knowing where?
What they're using is the newest, latest, and greatest out on radio control helicopters is what they call a 3-axis gyro. And this helps the RC pilots to be able to fly these complex helicopters a lot easier. And I'm not an RC guy, so we'll let Tom get into that. But it has accelerometers, magnetometers, and gyroscopes all built into a tiny chip. And this actually senses where the rocket is in relation to 0 point. The 0 point, when we fire up the system sitting on the pad, the electronics is assuming that we're pointing straight up, we're at 0. And everything is measured away from that point.
So you got some sophisticated electronics in it, no doubt about it.
Yeah, it got pretty complex by the time we got it ready to fly.
Okay, now what are you doing for the recovery of the booster? We understand how the sustainer is going to light and the go, no-go signal. How's the sustainer going to recover? What are you going to do for that?
All right, after staging, we actually have 2 altimeters in the first stage, along with the radio control backup, and we're going to sense it off of and fire. The parachutes out is at apogee. And what I have is I have 2, I want to call them mortars, sitting alongside the parachute in the parachute bay. And at apogee, there's 2 2-gram charges of black powder that will fire these mortars and knock the cover off that covers the lower parachute bay. This also is holding the airbag. There's an airbag that actually assists in the staging of the 2 rockets, give them that initial shove apart. That's what houses the airbag. So we're going to use these mortars to push this plug out of the way, and this will also, what we're using, we're attaching a pilot chute to. So as this comes out, it's going to pull a pilot chute out. Pilot's going to pull the main out, and we're going to recover the whole thing under a 28-foot main.
Okay, but you still, to connect these 2 halves together, you did like the Saturn V, where you have a rotating disc that locks into place, and that's got to untwist, the airbag's got to go off, you get the initial separation, and then you're going to blow those 2 mortars out. Is that the same?
Okay, well, we have the actual staging process begins with a timed event. We know our burn time on our P motor. So what we've set the Xavier timer for 6 seconds. So right at burnout of our P motor in the bottom, we are going to start a sequence of events that stages the rocket. The first thing that happens at 6 seconds, we send a signal to 2 seatbelt pretensioners, which is an explosive device that has a cable sticking out of it that I can use to turn an aluminum disc. When we assembled the rocket, there's an aluminum disc in there with keyhole slots in it. And what these keyhole slots do is they lock into 8 pegs sticking up out of the first stage. So as we lock this disc, that effectively locks the 2 halves of the rocket together. To unlock them, we're using the seatbelt pretensioners. They will actually turn the disc, and that puts it to the wide part of the keyhole, and now we have 2 halves of the rocket that are no longer locked together. On this disc are 3 switches. So as soon as any one of these 3 switches is closed, it sends a 12-volt signal to an automotive airbag, the same airbag that you sit behind when you're driving your vehicle, that will send the signal to the airbag. And we have the airbag sandwiched between the 2 pieces of the rocket. As the airbag inflates, it will inflate the nylon bag and actually push the 2 rockets apart very quickly. They're very powerful devices. They save a lot of lives in automobiles, and we just figured a way to incorporate it into our hobby.
Well, you've used this in the Saturn V before, right?
Yes, this is how we push the 2 halves of the Saturn V apart. The upper stage on the Saturn V weighed about 350 pounds. The second stage was 1,000 pounds. It very effectively pushed the 2 apart and allowed us to get our parachutes out.
So this is proven technology you're just incorporating in the second product?
Yes, everything works so well. With the first one, I saw no reason to change the design. We modified it to make it fit this model, and using a lot of the same technologies.
Good. All right, now the recovery of the second stage. Now we've talked about the fins, how they're going to come out, how they're going to go back in. How's the recovery going to work on the second stage, and what happens with that?
Okay, second stage, whether the second stage motor lights or whether it does not affect the recovery of the upper stage at all. We have 2 altimeters in there, an Arts 1 and an Arts 2, and they will actually sense apogee of the rocket, with or without that second stage flight. We also have a WRC2, which is a radio control, radio actuated device that we can bring our recovery systems out with. The complex thing we're doing with it is we're going to try to 2-stage recover the upper stage. The upper stage weighs somewhere in the neighborhood of 350 pounds. We don't want to put out a main chute at apogee because we're going to be traveling a long ways to get it. So we're bringing out about an 8 or 10 foot diameter drogue chute at apogee. We're using a gas generator off of an airbag to pop our nose cone off. As the nose cone pops off, it's going to drag out a pilot chute, which is going to bring our drogue out. At 1,500 feet, we're going to bring out a main using via descender tender. So we're going to fire another explosive charge. We'll actually release that first chute, and in the process of releasing the first chute, we're going to pull out a pilot and a main for the main recovery, which is also a 28-foot diameter chute.
All right. And then does the capsule stay on by itself, or is it under its own chute? Is it tethered to the rocket?
The capsule will actually come back via the drogue. We are ready to be down at 1,500 feet, so the drogue takes over the capsule only.
Is the capsule going to be horizontal? Is it going to be one end?
No, it's going to be lying up, hanging upside down. We're going to stick it in the ground. Yeah, this is actually the same capsule we flew on the Saturn V. It's autographed by Walt Cunningham, who actually flew on this rocket, mission SA-205.
All right.
So it's got its blessing from a veteran pilot.
So this is a remake of the Apollo 7.
Yes, it is. It's one of the prettiest rockets as far as paint scheme. A lot of the rockets look similar, but this is actually the neatest looking one as far as paint scheme, so that's kind of the reason we went with it. That and the Walt was involved with it.
Is there anything else you want to say that I didn't bring up?
Oh, just a thanks to Rockets Magazine, MDRA, all the people that dug into their time and their wallets to make this happen. Getting into these projects it's such an undertaking. You really can't begin to fathom the amount of work and money that it takes. And without the Rocketeers, without the support of everybody involved, including just the massive amount of time from people, it could never happen. So I'm very grateful to the hobby, the hobbyists, and the club members that make it all happen.
Now, do you remember all the vendors that helped you?
Okay, beyond all the people, I think we had a lot of sponsors involved. Hartwell True Hardware in Ohio. We got Loki Research. Some of the last motors he made were actually motors for this. We have Descender Tender, graciously donated equipment to get a 2-stage recovery out of our upper stage. Rocket Electronics, Frank Hermes and the tilt meter. This is something that's being recently released. Be available to everybody here very soon. It's one of the first ones that have been flown, actually, I believe, outside of Frank's testing and personal use of them. FM Machine actually fabricated my base plate on my rocket and did some other machine work for me on the adapter for the upper stage. I have Higgs Farm here. Without this property to fly on, we wouldn't be flying this either. Eugene and Tommy are great. Eugene's always coming up wanting to know what's new on the drawing board, and he just loves rockets.
He wants big projects, yep.
Yeah, he likes the big ones. I think we've accommodated him again. Ozark Aerospace, we're running with almost all of Ozark Aerospace electronics in here. We have telemetry to the ground. We have 5 arts, I believe, in here. Yeah. So yeah, we definitely got Air Call and Ozark Aerospace represented again. They did us a real good job on the Saturn V. So we're going to run with them again.
Well, you got a GPS, so you know where the rocket lands in case you can't see it, right?
Yes. Yeah, we don't want to lose this. Eve's Graphics, my brother owns a graphics company, actually cut the lettering out for me, and he's also did most of the work on the t-shirts. Thanks also to Bob Utley, helped get the design put together. PPG, got a black and white paint on here, and same thing on the Saturn V. They've been very supportive, and the paint and the materials. Everybody said, "What kind of paint is that? That's gorgeous." Well, that's PPG automotive paint. And the Saturn V is still down in Huntsville, Alabama, sitting in the Alabama sun, and I get reports that it's still looking real good. So, yeah, my wife's very understanding and very supportive. She hasn't seen me much at all for the last 3 months. I'm sure Vern's wife's about the same situation, because he says his last 3 months has been a big blur. But he's got a gorgeous, gorgeous model, and he spent a lot of time on it.
My name's Tom Erb. I'm actually from Marlboro, Ohio. It's probably about 5-6 miles away from where Steve lives. I helped Steve out quite a bit on the first Saturn V project, and got got called back to help with the 1B.
Okay, so now were you the guy that decided we needed another rocket to build, or?
Well, Steve always wanted to do another rocket, and he was tossed around between maybe a V2, trying to decide what he wanted. I did kind of coax him along as the Saturn 1B because of my love for this rocket to begin with, and kind of a, it's a salt and pepper thing. He's got a 5, you need the other one to go with the set.
Yeah, everybody's done a V2.
Yeah.
So, did you take this on the road to any of the hobby shows, like you did the Saturn 5? You took the Saturn 5 to a hobby show, and you got some kind of award for that. What was that? Did you bring this to the same place?
Yeah, that was the Weak Signals RC Club has a big trade show up in Toledo every year. It's probably one of the country's largest RC-related trade shows. They have it right downtown. The Saturn V we took up there and got a director's award for achievement, just because of the nature of and scope of what we had done with the 5. And we were well received with that, so we did take this one up here a year ago to display it at the Toledo show, and got a very good reception and welcome from them again. It really doesn't have a category at that show, so it did not receive an award per se, but they were extremely grateful that it was there. So.
They remember you from the Saturn V?
Oh, they absolutely did. In fact, the trade show was just a few weeks ago, and I had a lot of people ask me how this project's coming and when it's going to fly, and they're all waiting for the flight.
Yeah, today's a rainy day. Okay, now I understand you have some RC on board this, I guess in both the booster and the sustainer, correct?
Correct. Yeah, on the upper section and all along with the Saturn V project, we were looking for some ground-based backup for the recovery system, just in the event we had an issue with any of the onboard arts computers. On the second stage of this rocket, we do have a missile work system which was used on the 5 and worked quite successfully. And then because for the first stage on here, because we only had one missile work system, I've added a Futaba RC system to the bottom, utilizing just a simple receiver and a simple servo, which is a mechanical control that I use on all my RC airplanes and helicopters now. That has an arm on it that rotates up and trips a micro switch to detonate the pyro charges that will blow the parachute system out. And
this is the 2 mortars he's talking about?
Right. Yeah, we have two about 1.75 inch, 2 inch diameter mortars that are going to blow the cover plate off, and attached to that cover plate will be the pilot chute that'll bring out the main chute.
Okay, so this is a manual backup to make sure the cover comes off and the chutes come out.
Absolutely. We have 2 mortars, one each for redundancy. One or the other can fire. They're both going to fire simultaneously because of the way they're wired, and should, but if one charge failed to ignite, it's not a problem. We've got another one there. If they both work, it's even better. During testing, we found that the mortar would work extremely well after Steve put it through a hollow core door in the shop, so we know it's going to go.
And I understand Steve put quite a few holes in this
yeah.
this time around.
Yeah, there was some experimentation, and our early design didn't quite do what we wanted to do at a later point when we were testing it again. So, it was kind of a modification that we made, and we're really happy and confident that it's going to do what we want it to do.
Now, in the upper stage, Steve was talking about Frank Kirby's tiltometer, but you also have a different kind that he said is used on RC helicopters, as gyros and some other stuff on it. Can you explain what that is?
Yeah, in the RC industry, we use, especially on helicopters, we've always used electronic gyros to stabilize the tail rotor system. The newest thing out in RC helicopters is a 3-axis gyro system that will give you better control over a flybarless head. This is the mechanical input. What we've got here is real similar to Frank's tiltometer in size and shape, and what it is, it gives us a cone of flight, or a certain amount of angle from vertical that will allow we will allow the rocket to still ignite the second stage. If it gets outside of that parameter, then it'll shut down the system that will ignite the second stage motor, because we'd rather have the upper section, if for some reason it goes errant when we separate, we'd rather have it not fire and just go into recovery mode, come back down to live another day, than to take off, in an errant direction, which could be detrimental to the safety of the rocket and everybody else around it. So.
Okay. Is there anything you want to say that I haven't asked while on camera?
No, not terribly.
Well, who makes the electronics for the RC that you're using?
Oh, the system I are using for that is a Futaba. It's a 12Z transmitter and a 6008 receiver, and with a 3004 servo. I am basically what you call a field rep for them and flying their equipment. It's very, very dependable equipment. It's the latest in 2.4 gigahertz design, and I'm quite confident and have tested it extensively to know that it'll work in this environment.
Now, is this 2.4, is this encoded so that only you can talk to it and nobody else can?
Absolutely. The receiver is actually linked directly to the signal on my transmitter load. Has its own encoding. There is no outside interference possibility from any other unit because of that. Yeah, with a fully encoded signal, there's just the chance of having any interference from it is virtually zero. Nothing's perfect, but it's virtually zero.
Well, now you spent what, 18 months helping Steve do this?
Yeah, I had the pleasure of helping him quite a bit more with the build than I got to on the 5. He had got moving on the 5 really before I even knew he was actually doing it. The 5 started at a poker game as a sort of a dare. Next thing I know, he's showing me pictures of the frame. So I came in a little late on it, but I'm doing the same thing on this. Basically, I did the other as far as doing the RC, the backup systems for recovery, but I did get to help him quite a bit more with build and paint, which was really a lot of fun. So.
Okay, is there anybody you want to thank?
Just thanking Steve for all his tireless efforts, and allowing me to be on this ride. Of course, the guys out here at MDRA are the guys that make this happen, and you always got to thank God above for everything we get. So. Oh, absolutely. I can't thank my wife enough for putting up with me. So, and yeah, she was. I was really hoping she'd be here this weekend, but she was a little under the weather and couldn't make it. So, but there'll be other days.
She might be the smart one of the bunch.
She might be.
Tell me what your position is, too.
Bob Schoner. I am a director on the Tripoli Board of Directors. I'm here undercover to find out what the hell, cut that. I'm here just to enjoy a launch at MDRA. I've been accused of all kinds of things because I haven't been at a launch in the 8 years I've been in Virginia, and it's close, and Neil thinks that DC, Virginia is the same as Western Virginia, but I'd love to come launch at MDRA and watch what happens. And it's a great landowner, great club. They do a lot of great stuff. Recently donated some funds to a rocketry club in Japan, and I think they are a great model for how to help foster a relationship with the landowner, how to pay back to the community, and how to host great events. So I came to see what it was all about.
So what do you think of the 2 Saturn 1Bs that are sitting next to you?
I really think they are amazing. Two beautiful rockets, incredible detail, incredible, vision just to be able to do something like this. I keep thinking that as Tripoli grows, maybe not everybody's going to bust 100,000 feet, but to pull off something like this, just amazing craftsmanship and work. And I think the rest of the rocketry community respects the Steve and Vern for their vision and for pulling it off. Just amazing.
I think you found that there's more to it than just a pretty rocket. They put a lot of time and some thought into how they cover it, how they're going to fly it, how the rocket's going to work.
Yeah.
You know,
Yeah, just listening to Steve, I mean, the guy's thought of all kinds of stuff. There's redundant systems and fail-safe systems if the rocket isn't within 20 degrees of vertical. Just really well engineered, some great technology, really cool stuff.
now, yesterday we were here putting it together in the, what was it, 40-mile-an-hour wind?
Yeah, gusts of 40, but it was sunny.
And today the weather is,
I think the meteorological term is sucky.
there you go. And tomorrow they're calling for what?
25 to 35 mile an hour winds, I believe, but sunny.
Sunny.
Yeah,
So we're getting close.
yeah, we're moving in the right
Just gotta
direction.
have this banged out, right?
Yeah.
All right, so is there anything you want to say that I haven't asked you?
I'd like a new watch for Christmas.
Well, that's good. You don't have any campaign speech for next year? I don't even know if you're running or not.
No, I think not this year, but next year. My term expires. I haven't decided if I want to rerun or not. I feel like I want new blood in the BOD. I think new ideas, fresh ideas, people who haven't, I guess, been brought up thinking this is the way things are. I think we need some younger folks. We got a bunch of, seasoned people in the board, and they're good people. But I'd like to see some younger folks step up and infuse us with new ideas and new energy. So,
Since whether you run or whether you don't, up until this point, what are you most proud of that you helped instrument for Tripoli, or part of that you helped Tripoli institute?
probably the most, I don't know if it was most visible, but I kind of drove the effort to get a new magazine, to do the proposal for that and drive that, and reviewed the submissions and selected the best one. I guess other than that, I am really grateful to be in a little district courtroom in DC and hear a judge prevail with our opinion that the ATF was overstepping their bounds. There was less than 10 people on our side in that courtroom, and I don't think the majority of Americans know what a great victory that was for this little rocketry community. That was pretty amazing.
Yeah, you guys went through a lot of thick and thin, a lot of pain, struggles, and you persevered. And I know at some points I was watching going, it's never going to happen, but
Yeah, I mean, to me the facts were, it's cut and dried, it's simple. But getting the judge to understand that and see our point of view, the ATF based it all on burn time. They did some research and got it completely wrong. And we prevailed in that, and that was a tribute to a lot of people. I think while we were waiting, people could wring their hands and go, well, what if they do this? What if they do that? Just fly your rockets, enjoy the hobby with the limitations we have, and hope for the best. And I think we're in a good position now. It's time to grow and do more cool things like this.
that's what we try to do. I think we all try to do it in our own little way.
Yep.
Well, I want to thank you for coming out.
Well, it's good to be here. Rain's slowing down. Are we ready to pop these off?
Now, I think we're going to wait for the field to dry just a tad.
Okay. Yeah, but it's great to be here.
When we get all the way in there, you can flip the ramp. Okay. After we get all the way up in there. Step on that ramp. Going down. Got the other horse then? Okay, we can set her right here. Safe. And put that horse as far back as possible.
Watch, is the tip okay?
Yeah, we're okay. I'm down.
Well, I'd put it on the wheels.
Do you want to use the wheels, or do you guys just want to?
We carried this before, didn't we? Yeah, but it's gonna be a whole lot easier on wheels.
This is only 200.
No.
You can get closer.
Yes, sir. Way easy.
Right up
Make
the
sure he
ramp,
gets on
Vern.
that ramp.
Right out. Someone come to guide here so we know.
Yep.
Because I have no idea where I'm going.
You're all right. Just keep going straight. Watch behind you, though. You're just coming up on that.
We don't need that on our kitchen or no.
Okay, Vern, you're there. He doesn't want that. He's going to set it right down.
Nope, I'm sitting it right back down.
You gonna put it right on the coupler piece, you all right?
Yeah, I will put,
Okay, remove the 3 lock bolts. Like that. Plug on wiring for airbag. I did that, and I taped it. Route wires taped connected. They were wires were fine.
Hi. Dan?
Yeah.
This wheel's right on the edge, so angle that way just a little
Favor
bit.
that side, guys, so you get one of the
Okay, square back.
There you go.
All right?
Square back. A little bit to the left.
Don't go too much further,
Great.
because you got to drip right about where your feet are.
What?
Drop it here.
Oh, grip.
That's fine then.
Okay.
Yeah, let's get this Bob Shunner doing something. Oh man, you're right in front of him, Tom. Can't see you did any work. Look. Another piece of wood. Look at that. We got it. We got it on camera. Look at
Now
that.
the trailer won't roll.